All right, everyone. Hello, this is Miss Detterman. And this video is going to ultimately show you how to write an equation from a graph. And that equation is based off of the one from math class, hopefully most of us are familiar with, called y equals mx plus b. And we're going to call this new equation, after we've changed everything in y equals mx plus b, a mathematical model. So we're going to take y equals mx plus b, and y is going to become something new, m will become something new, x becomes something new, and b also becomes something new. Now, slope, hopefully you know by now, is going to be m. Y-intercept is the b. And these are two things that become a number. The tricky thing now is that x and y become a new letter. You're going to replace them with what is actually on the axis. So let's take a look at a graph and determine what would be two good letters for x and y now. So I have a graph up here. On my y-axis, I have extension. On my x-axis, I have mass. So y is actually extension. So instead of y no longer seems like an appropriate letter for the word extension. We will use the first letter from that word, which would be E. Then we are going to look at X, and X is actually mass. And X, again, this doesn't feel like an appropriate letter anymore if the word's actually mass. So we're going to use the first letter of the word, which is M. And usually that's a pretty good rule of thumb. Use the first letter of the word from the axis. But occasionally there's a little weird words. So there are a few weird letters that we're going to come across this year. And don't worry about them right now. We're going to address those as they come. For example, we will have the word displacement. And you'll want to use D. However, it's actually X. And that's a good reason why we can no longer use X, because every time we write an equation, y equals mx plus b, if we're going to look at it through the eyes of a physicist, we think we're talking about displacement. But we're not. So we need to make sure that you replace X with what's actually there and Y with what is actually there on the axis. The other trick to it is that typically when you're looking at a graph, the units are going to be in parentheses. And oftentimes I find students using the letters from those parentheses, and that would be incorrect. We want a word from the x-axis and a letter for that word, not the units. Because the units were how it's measured. The mass, the word, is what was measured. Our equation should have the what. So now that we've determined good letters for x and y, the next thing from y equals mx plus b that we need to get would be our m, aka our slope. So we need to go to our graph and figure out what is the slope. My first step often is when I look at the x and y axes, I need to figure out how much each line goes up. So on the x-axis, I've noticed that only every 4 lines is labeled. And every 4 lines goes up by 2. So it goes 2, 4, 6, 8 for every 4th line. But how much does each line go up by? The way that I figure this out is I take the labeled number, 2, and I divide it by how many lines It is. So this is 1, 2, 3, fourth. It falls on the fourth line. So I will do 2 divided by 4, which equals 0.5. So that means every line here actually goes up by 0.5. And I've just labeled a few of them. Then let's go ahead and look at the y and figure out how much y goes up by. I'd notice that it's every 2 lines that is labeled, and they go up by 20s. So I'm going to use the number that is labeled, 20, and I'm going to divide by however many lines that was. So 1, 2. So I'll do that. 20 divided by 2 equals 10. So each line actually goes up by 10. Just labeling a few of these points. Now that I have my lines, my scale figured out, how much each line goes up by figured out, I can now go in and calculate slope, and I'm going to show us rise. Ooh, that did not write correctly. Rise over run. Which rise over run is really the change in the y over the change in the x, meaning how much did our graph go up and how much did our graph go over. So this line right here, let's find some spots along our line. Notice that there are some dots from this data that don't really fall perfectly on the line. That's okay because they drew a line of best fit here. And we're going to take our slope from that line of best fit. So we need to figure out, where does this line perfectly cross some of these T's that you see in the grid lines of this graph. So the way that I do this is I love to draw my T's along them and try to find a spot that would be really good for this. And this one is looking like a really good spot. And let's go back up here. There was another good one up here as well. And that would be right here. So I've got my 2 dots where they make a perfect little T. And we need to figure out how much it goes up for our rise and how much it goes over for our run. So from here, from my first little dot, we need to figure out how much it went up. Now, it's tempting to count 1, 2, 3, 4, 5, 6, 7, 8 and say 8 was our rise. We can no longer only count by ones when our graph doesn't increase by 1. This graph on the y-axis actually increases by 10s. So this wouldn't be 8. It's really 8 times 10. This is actually 80. Or you could count by 10s and go 10, 20, 30, 40, 50, 60, 70, 80. So my rise would be 80. Then I need to figure out my run. How much did it go over? From here, I'm going to go all the way to my dot, and I'm going to count the amount of lines, but I'm going to count by 0.5 now because each of these lines is actually 0.5. So this is going to be 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5. That would be, my run is 5.5. And that would equal 80 divided by 5.5. So if we type that into our calculator in just a second, sorry for the noise, I'm moving my laptop. If we type that into our calculator, we will do 80 divided by 5.5, and that would give us a total of the slope being 14. And I'm going to round here, 14.55 is our slope. And again, it's really tempted to count by ones, but we can't count by ones anymore when our x and y don't increase by the same amounts. These increase by different amounts. So we actually have to count by how much each line equals. So we have a slope of 14.5. From there, we need to figure out our y-intercept. So we figured out y, we figured out x, we figured out our m, but let's figure out b. Give me a second to erase. M equals 14.55. Let's find our y-intercept. So let's erase our work on the slope here. And the y-intercept is just where does this line that was graphed run into the y-axis, which is that line that is up and down? Where do they run into each other? Where do they intersect? So I'm circling that right here. And that would be right here where this line crosses that y-axis. So this line crosses the y-axis, and the y value here would be 0. So our y-intercept is 0. Then we take y equals mx plus b, and we now rewrite this where every letter is something different now. Instead of y, I'm going to write e. Instead of m, I'm going to write 14.55. Instead of x, I'm going to put m. And instead of b, I'm going to put 0. And so I'm going to add my 0. Then I will simplify this by doing e equals 14.55 m. And that would be my final answer. What I want to do at the end of this video right now is I would like to actually go over how to calculate slope using the slope-intercept form. And that's what this is here, but using the slope equation to find our slope. So I'm going to erase a little bit. And let's go to the slope equation, which is slope, Rm, equals y2 minus y1 over x2 minus x1. This process does the same thing where we need to find those two dots along the line. So again, find a place along that line where it crosses nice and perfectly. So we had one earlier that was right about here. And then our second one we said was up here. Once we've identified our two places, we need to find their coordinates. And I will always write them in parentheses near the dot. So for this dot right here, I'm going to go straight down and figure out where this is on the x-axis. And that would be 7.5 if each line goes up by 0.5. Then we also need to figure out what the y is. And it's halfway between 100 and 120. This is 110. And then down here, we need to figure out what the x is, which this one is 2, and what the y is, and that is 30. Next, after I figure out what the coordinates are, I go ahead and label them. Since the dot right here is to the left, that's going to be the ones. This will be x1, y1, and this will be x2 and y2. Now that I've identified what each of them are, I can plug them into the equation. M equals, and instead of y2, I'm going to put my 110 minus my y1 of 30. Then divide that by x2, which is 7.5, minus x1, which is 2. Then I can simplify. 110 minus 30 is 80. 7.5 minus 2 is 5.5. When I type that into my calculator and divide, I'm going to get 14.55